Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem. Count pairs whose sum is less than target. Okay. So what the problem is saying is we'll be given an array and an integer target, and we have to find the number of pairs in the array whose sum is strictly less than target. Okay. So here is a given array. Okay, and here is a given target, and we want to find out all the possible pairs whose sum is strictly less than the target. So what are those pairs? Let's quickly have a look. So one of the pairs is 2 1, right? 2 1. Another pair is 1 3, right? Another pair is 1 4. Another pair is 1 5. Another pair is 2 3, right? And another pair is 2 4. So these are the six pairs. These are the six pairs whose sum is equal, is less than, is strictly less than the given target. Okay. Okay. So that's what we want to find out. We want to return the number of, we want to return the count of such pairs. Okay. Okay. Now, how can we solve this problem? So first of all, let's solve using the naive approach. Okay, solve using the naive approach. Just one request before going through the approaches to please subscribe to the channel, like the video, as I'll try to make it very easy for you. Okay, thank you so much. So what we'll do is we'll have two for loops, right? One will be I equal to 0 to n minus 1, and another will be for j equal to I plus 1. Okay, to n. Okay, to n. So these two for loops will go through all the possible pairs. Okay, we'll go through all the possible pairs and we'll take a count variable. Okay, and what are we going to do? If arr of I plus arr of j. So the element pointing at j will always be ahead of the element pointing at I. Okay, arr of I plus arr of j. Okay, if it is less than target, then just increment the count. Just increment the count. So this approach will solve your problem, but the time complexity, it will be O of n square. Okay, why O of n square? Because we are having two for loops, right? We are having two for loops. Okay, okay. So now this was a naive approach. So we need to solve this problem using better approach or expected approach. Okay, so let me erase this first. Okay, now how can we solve this problem? So what we can do is we can sort this array. Okay, we can sort this array. So the array will look something like this: 1, 2, 3, 4, 5, 6, 7, and 8. So this is our sorted array. Okay. Now, now the array is sorted. So what we're going to do is we are going to solve this problem using two pointer approach. So we'll have a left pointer and we'll have a right pointer. Okay. Now what we're going to do is we're going to check. We're going to take the sum of these two pointers. What will the sum be? A plus L, L plus A plus R, right? Which will be 1 plus 8. Okay, 1 plus 8. 1 plus 8. Okay, which will give us 9. Now we're going to check. Is the sum lesser than the target? No, it is not. It is not lesser, right? 9 is not lesser than 7. So what we're going to do so we want to reduce this sum. We want to reduce this sum. So what we're going to do, we're going to decrement our R. Okay. Okay. In order to reduce the sum. Now again, we're going to take the sum L plus R. L plus R. What is L plus R now? 1 plus 7, right? 1 plus 7, which is 8. It is still greater than the target. So again, we want to reduce this sum. So we're going to decrement our R. Okay. Now we're going to take the sum again, 1 plus 6, sorry. 1 plus 6, which is 7. It is still not less than 7, right? It is equal to 7. It is still not less than 7. So we want to reduce this sum. So again, we're going to decrement our R. Okay. Now our L and R both are pointing at 1 and 5. So we're going to take the sum again, 1 plus 5 equal to 6. Now this is lesser than the target 7. This is lesser than the target 7. So we have found a pair. Okay. What is that pair? 1 and 5 is one of the pairs. Now, if you can see, so this is the extreme end, right? This is the greatest sum, okay, which is less than the target. Okay, so that means, what it means is this one will be, can be paired with this particular element, this particular element, and this particular element, and it will still give less than target. So let's quickly check. So what is our one pair we have found? 1 and 5 is a pair, right? 1 and 5 is a pair. Now, if you check 1 and 2, 1 and 2, okay, if you take the sum of this, which is 3, definitely is less than target. Similarly, 1 and 3. 1 and 3 again is another pair, and 1 and 4 again is another pair. So what we're going to do is what we're going to do is we are going to take a count variable and we will add. For example, we found a pair. Okay, we have found a pair. Okay, where whose sum is less than target. Then we are going to use this formula, right minus left, right minus left. Okay, which will give us the count of all the pairs. So if you check what is right here, what is right? Right is pointing at what is index 0, 1, 2, 3, and 4. Okay, right is pointing at fourth location, right? So 4 minus what is left? Left is 0 equal to 4. So we have found four pairs. And what are those four pairs? Here are the four pairs, right? 1, 5, 1, 3, 1, 2, and 1, 4. So these are the four pairs, right? So let's go ahead now. Let's go ahead. Now, what was the state? Again, let me rewrite this so that you'll understand better. Okay, let me rewrite this array again. 1, 2, 3, 4, 5, 6, 7, and 8. So our count is what? Our count till now is 4, right? Our according to this formula. And where was our L? L was here. Our R was here, right? Now, when we find a pair, when we find the pairs, right? In that case, we are going to increment our L. Okay, we are going to increment our L. Now we're going to check again 2 plus 5. 2 plus 5 is 7, which is not less than the target. Okay, so we're going to reduce our R. Okay, now we're going to check again 2 plus 4, which is 6. 2 plus 4, which is 6, which is lesser than 7. So we have again found a pair. So in this case, according to this formula, what is right? So 0, 1, 2, 3. So right is what? Right is pointing at third location, minus left is pointing at one location, right? So which will give us 2. Okay, which will give us 2. And what are those two pairs? What are those two pairs? So our L is here, right? L is here and R is here. So one of the pair is 2 comma 4, right? Another pair is 2 comma 3. Okay, another pair is 2 comma 3. 2 comma 3. One pair is 2 and 4. Another is 2 and 3. Okay, and that is why this is 2. So we're going to add up in the count. So now count becomes 6. Count becomes 6. Okay. Now our L is here and our R is here. So when we find the pair, we are going to increment our L. Now L and R. Okay, so 3 plus 4 is 7, which is not less than target. So we're going to reduce our R. We are going to reduce our R. Now L and R are pointing at both the same location, right? And we are going to break out of our while loop because a while loop will run till L should be less than R. Okay. Okay. So this is the intuition behind solving the problem. I hope you have got the intuition. I think you'll understand better when we go and code. Okay. So before going to the code, I'll just request you please subscribe to the channel, like the video. Okay, let's quickly solve this. First, I show the Java code followed by C++. So let's sort the array. We'll also discuss the time complexity. Okay. So sorted the array. Now what are we going to do? We are going to take a left and right pointers, right? Add dot length. We want it to point to the last element. And we'll run a while loop, which will run till L is less than R. Okay. Int, we're going to take sum equal to arr of L plus arr of R, right? Arr of L plus arr of R. Okay. Now what we're going to do is we're going to check if sum is less than target. In that case, we're going to increment our L, and also we're going to take a count variable, int count equal to 0. Okay. Count plus equal to R minus L. Okay. R minus L. As we have already discussed this formula. Okay. If the sum is greater than equal to target, then we are going to reduce our R. That's it. And we will finally return our count. Okay. Let me compile this and we'll discuss the time complexity and space complexity. Okay. There's some mistake here. What is the error? Sum is less than target. Oh, sorry. We should be incrementing our L after this formula. Okay, let me again compile this. Okay, now it seems right. Let me submit this. So what will be the time complexity here? So sorting an array will take O of n log n. Okay, and rest this process, this code, it is going to take O of n. So we are going to take the greater, whatever the time complexity, which is O of n log n. Okay, and space complexity will be O of 1 because we are not taking any extra space. Okay, thanks for watching. The test is a passed. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. So with the C++ code, we are sorting the array. Then we are taking our left and right pointers. We're taking the sum. We're checking the target. If it is less than target, then increment the count with right minus left and increment the left. And if the sum is greater than equal to target, then decrement the right. Okay, and finally return the count. I'll attach a code in the description section. Thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.